welcome to another end-to-end ETL data pipeline. And in this video, we are going to be using Databricks for developing our data pipeline. And basically, with Databricks, we can basically programmatically deploy, and manage Databricks resources like our jobs, our data pipelines, also our ML models, if we are to also develop that, and then also deploy experiments and every other asset that used for configuring the pipeline itself. So basically, with Databricks Asset Bundle, we can deploy all the resources, including the notebooks, the Python modules, the Python notebooks as well, and every other resources that are needed for a particular pipeline. We can deploy it all as a bundle, and then basically we write our code once, and then we deploy to different workspaces. As you can see here, we have here as our local development environment, where you have your laptop on your VS Code and then you're developing locally. And then we have different workspaces for our project. We have the development, the staging, and then the production workspaces. But for this particular project, we're going to be using just two workspaces, the development and then the production. We are going to skip the staging. And then what we are basically doing here, we are going to programmatically define our resources, then deploy them to different workspaces. So we are developing once, and then we can deploy to different workspaces by basically configuring our various configuration files to help us do this. So here as well, we are going to implement the CI/CD, which is the core part of Databricks Asset Bundle, because with the CI/CD, we can also automate our testing and then our deployment. We can actually build our data pipeline using just Databricks notebook, but if we do that, it will be difficult to actually carry out our integration and unit testing. So, but with Databricks Asset Bundle, it will be easy for us to integrate our integration and also our unit test, so that at the end of the day, when we deploy maybe to using a GitHub Action, we can also always manage our testing and then deployment. So if all the tests pass, then we can deploy from the development workspace to the production workspace using the production data. So that is what we are going to be doing. So here we have the project bundle or the asset, which we are going to deploy to different workspaces. And then we are going to automate this deployment using our CI/CD pipeline. Basically, in our case, you're going to be using GitHub Action for this. So basically, in order to do this, we are going to be implementing this using a Databricks medallion-architecture, where we are going to have different layers. So we are going to have the bronze, the silver, and then the gold layer. So here we are asking the question, what happens in this layer? In the bronze layer, we have the raw data ingestion. Basically, the bronze layer is like staging the raw data it is without any modification. So we are going to have that here. And then maybe perhaps using Autoloader, but in our case, we are going to use Autoloader. And then in the silver layer, where we are going to apply our cleaning, transformation, and data validation. So this is what we are going to be doing in the silver layer. And in our case, we are going to have our fact and dimension tables here. And then in the gold layer is basically where we are going to have our aggregated data or our business data, as you may call it. And then this is where we basically connect our BI tools to stream our data. But depending on the case anyway, our BI tool can also become connected to our silver layer if we actually want it in real-time reporting. And if it's acceptable to have it in batch reporting, we can actually plug it to our good layer. Because most time good layers are aggregated and they are usually windowed. So if they are windowed, that means it's basically for like maybe say every 5 minutes or every 2 minutes or every 10 minutes. So it might not be in real time. So, and who is the intended user here? For the bronze, mostly data engineers, then data operations, compliance, and audit teams. Most times, data engineer handles most of these tasks within this bronze layer, because the data engineer is in charge of the initial, data migration part, where you have to bring the data to Databricks platform and then apply Delta Lake on it. So basically, the data engineer is in charge of this part. And then the silver layer, the data engineer, the data analysts, and data scientists for building the models, because now we have clean and the validated data here. And then the gold layer, basically every other person, and also the end users and the executive who can actually query this good layer to get instant insight. So then here we have the movement of the data. For this particular project, we are going to have the historical data in our Google Cloud storage, and then we are going to have the real-time data coming from our Google Cloud PubSub. So that will go into our real-time raw, while the historical data will go to historical raw. So both data are kind of similar. So, and then we'll then merge it during the silver layer to flatten the property data. In this case, this is going to be a temporary table, so we are not going to see the actual table within our Unity catalog. So this is just a temporary table. From this temporary table, we are going to create the table which you are going to see in our silver layer within our Unity catalog. So we are going to have our fact table, we are going to have our dimension table, and then we are going to have the quarantine table. So after our data validations and all that, there are rules that we are going to place to actually validate our data. So for the data that are not passing those rules, that are failing the rules, they will be sent to the quarantine table. So for further inspection. Then for the ones that will pass those validations, they are going to go into the fact and the dimension table. So this quarantine table is going to contain the invalid data, while the fact and dimension tables are going to contain the valid data. And then from the fact and dimension tables, we are going to carry out our aggregations. So where we are going to have a validation table here, which is going to take its source from both fact and the dimension table. And we are going to have another aggregation, which is the neighborhood trend, which is going to take its data from the dimension table only. So this is how we are going to structure our table using the medallion architecture. We can see this properly here. You can see the sources, though this is not our own project, but just this is the flow of data. You can see the sources here. Kafka, Kinesis, these are streaming platforms that can take a real-time data. And then we have the data lake, basically like our AWS or our Google Cloud Storage, and Apache Spark, and then AWS Azure and Google platforms. So this data will be injected from here into our bronze layer. Bronze layer will contain the real-time ingestion and the historical data, but in its original format. So here we haven't processed the data, so this is going to be our single source of truth. So here is just the original format of the data, but we are going to apply our data lake onto this layer, because at the end of the day, we are going to be using our data lake on this. So here we are going to have a silver layer, which is going to be flowing from the bronze layer. Here we are going to have the filtered, clean, and augmented, which is what we just discussed previously. And then onto the gold, which is going to contain the business aggregated data. So from the gold now, we are going to plug in our streaming analytics, BI tools, BI reportings, data science, and then every other thing that are needed for by the end users. That doesn't mean that we can't plug them into Silver Lake. We can do that depending on the use case anyway. So now let's talk about data warehouse, data lake, and then the data lake house. Basically, a data warehouse is used for storing processed data, mostly structured data, and basically you can apply ACID transaction to it, and then with a strong data governance. But in data lake, we can process every kind of data in their native format, like in their original format, structured, unstructured, semi-structured. It doesn't matter. Everything can go into data lake, and it's quite cheaper. So now the lake house now, which is a modern data architecture that combines the flexibility and low cost of the data lake with the reliability and performance features of a data warehouse. So basically taking the best of data warehouse and taking the best of a data lake and then combining them to give you this. So the interesting part about this is that within Databricks doesn't store the data are usually stored in the cloud platform that are connected to Databricks. It could be Google Cloud Platform, it could be AWS, depending on the cloud platform that is being connected to Databricks. So basically, you're not paying for storage cost in Databricks and then paying for the same storage cost in your data lake. No. What happens is that Databricks with a Unity catalog will store the metadata of whatever tables you are going to create within Databricks. So like the table name, the file location, so that whenever you query that any data from that table, it will use the table name and file location to actually retrieve the information for that particular query. So Databricks doesn't store it, but it stores the metadata of each of these tables that are created within the Unity catalog, which is one of the benefits of a Unity catalog. So you can see here, the metadata and the governance are sitting on top of the data lake. So there's no other extra layer. So this is just a combination of the best of the data warehouse and your data lake. So in summary, you can see that your data lake plus your data lake will basically give you the lakehouse architecture, which is what Databricks is using. So now let's deploy Databricks Workspace and enable our Unity catalog. And in this case, let's set up our Databricks on Google Cloud platform to basically start our project. So as you can see here, I'm already on Google Cloud. We have our real estate valuation project. We're here. If you check here, you can see several projects here, but you're interested in working with this real estate valuation project. So you click on it and come down here, search for marketplace. This is marketplace. Then here, type Databricks. So how Databricks, this is it, click on it. As you can see, we have 14-day trial because this is the first time I'll be using for this account. And then let's go down and see how much is covered in this free trial. Here you can see we have $10,000 credits, which we have to use for a maximum of 14 days. So after 14 days, we don't exhaust it, it basically expires. And if we exhaust it before 14 days, then we have to basically subscribe to Databricks by paying via Google Cloud platform. So, but at the moment, we can use this particular credit for 14 days. Now, these are the features that are covered. So let's go up. Let's hit on subscribe, our Google Cloud Platform billing account. And additional terms we are purchasing. So let's agree to this and then we'll say subscribe. So now you click on sign up with Databricks to continue. So basically, this will help us begin the setup. So click on it. So now we have to select, give it a company name, call this portals, and let's select the account to use. Say continue. So now we refresh the page and then click on manage provide. So this is tell you this, you are leaving Google. This link opens a partner site. Google isn't responsible for privacy or security third parties. So you say okay. So say continue with Google. Use the same account we just used, and then we see the subscription plan. Your 14-day free trial starts when you click continue. Thereafter, you will be charged at the list rate. So if you want to continue, you click on continue. So let's click on continue. So that is it. We have created our Databricks account, which is linked to our Google Cloud platform. So the next thing to do is to create our workspaces, basically our dev, our staging, and our production workspaces for this particular project. Let's create the workspace. The first workspace, which is our development workspace. So let's give it a name, real estate dev. Let's just call it real estate dev for now. And then the region for us is Europe West 3, which is Frankfurt. And then the Google Cloud project ID, let's go to Google Cloud. This is our project ID. So let's just copy this. So let's go back and paste it here and then save. So it's provisioning now. And this is our first workspace. I'm going to create another workspace for this project. We are going to use two workspaces, one for development and then one for production. So I'm going to create another workspace for production. So now let's start off our project. And I just opened a new Visual Studio Code. This is a fresh page. So let's open a folder. Name the folder Databricks Asset Bundle YouTube demo. So let's open this one. Now let's open our terminal. The first thing we do, we have to start up in the virtual environment because we want to isolate our dependencies and I want to build from the virtual environment. So in that case, I have to start from a virtual environment. Here, let's create a virtual environment. So now let's activate our virtual environment after creating it. So we are now in our virtual environment. And so the next thing to do is to install the various we are going to start with installing Databricks CLI because you are going to need it basically. So in order to install Databricks CLI, there are different options. But one of the options is type Ingest search Databricks. One of the options is to type Ingest search Databricks. Click on it. So we have Databricks.Databricks CLI 259.0 version. So now let's install. So we are now installing Databricks version. This is the version we are installing. Successfully installed. So we have installed our Databricks CLI. Now the next thing is to authenticate. So in order to authenticate Databricks, we have two ways we are going to do this. Like I said previously, we are going to basically have two workspaces which we have created in the previous video. We're going to have the dev workspace and the production workspace. And in order to authenticate, we are going to need each of the workspaces. You are going to need their host to do this. I'm going to show how you can get the host and able to authenticate with that. So in order to retrieve our workspace host, this is our Databricks development environment, as you can see here. So all you need to do is to click on this. Then we have the production, have development. So, but in this case, you go to manage account and then you click on workspaces. So first of all, we are interested with the development. You click on it, and then this is it. You just copy this. This is what we need in order to authenticate for the development workspace. So let's go back. So the first authentication is going to be authentication to the dev workspace. So paste this. So Databricks authentication login profile real estate development. So the host URL we are going to give is going to be represented each time with this real estate dev profile name. So click on it. It's going to request for our host URL. So here it said authenticated. So let's go back. So profile real estate dev was successfully saved. Now let's do the same for the development and production workspace. So authenticated again. So now we have authenticated both workspaces within this our local development environment. So let's verify our active profile. So as you can see, we have our real estate dev. This is the host URL, which I just showed you how to copy. Is it valid? Yes. We have the pod as well, which is also valid. So both workspaces are valid. Now, because from the beginning we said this is going to be a Databricks Asset Bundle project, and for us to have a structured Databricks Asset Bundle project, we have to initialize. And the initial initialization will basically give us a default structure. From this structure, we can build our project. So now let's initialize our Databricks Asset Bundle. But before we do this, we need to let's check our Databricks version to be sure that everything is in order. So this is our version. So now let's initialize Databricks bundle, which is for the initialization. Default, we are going to be using Python. And the profile here is the real estate dev, which we just created here. So here it says, welcome to the default Python template for Databricks Asset Bundle. Now, the unique name for the project, in this case, if we don't give it a name, it will use my project as a unique name. But in this case, we want to give it a name. So let's just call it real estate. So you can see why it failed. So let's call it real estate underscore. So it includes stop sample notebook in real estate underscore source. Yes, you can say yes. You want sample data live table? Yes, because you're also going to include a data live table. Python package? Yes. Use serverless compute. Initially we can say yes, but later on we are going to use classic compute, not serverless. So, but let's say yes for now. So now you can see our project. It has created our project, our Databricks Asset Bundle. From here, you can see the structure, fourth structure. You can see the test folder, which will contain the test, the source file, which is going to contain our Python notebooks and the modules that we are going to use for creating our data pipeline and also our jobs. And then we have the sources. Here we are going to define our data pipeline and also our jobs. But here there are default ones already, but we are not going to be using all this. We are going to modify them to what we need. So we have initialized our Databricks Asset Bundle. We have seen the structure, and this is our databricks.yaml file. This is where we are going to configure the target environments and all the number of environments we have. We are going to configure them here. Like we have the development stage in production, but in our case, we are going to have only development and then the production environment. So this is where we are going to configure all that. So let's begin by building our different layers for this particular project. We are going to be building layers for the bronze, like we described before. We're going to build a layer for bronze, for silver, and then for gold. And for the source code, we are going to build them under this SRC folder. So here we need to basically separate what we are building, because here we are going to be having the source code for our different jobs, and we are going to be having the source codes for our data pipeline. So here I'm going to have two folders, one for the pipeline and the other for the jobs. But for now, let me delete all these default folders. So now let me create a new folder here. Let me call it jobs. Create another folder, call it pipeline. So now we have two folders here, job and pipeline. So within jobs, we are going to create the layers, the folders for different layers. So here we're going to create for new folder, call it bronze, create another one, name it silver, then create another, name it gold. So these are our layers. So each layer is going to serve as a package because each layer is going to contain the different modules, Python modules and notebooks that are going to be connected to our resources at the end of the day, which basically create our data pipeline, and the lineage must be also followed. So here we have the bronze, we have the gold, and we have the silver layers. So within each, we are going to create the files. So now let's create the files within these layers. As for the bronze layer, we are going to have several files. Here we are going to have the schema validation file, and then we are going to have the Python module that will basically hold our autoloader, and then we are going to have the main Python notebook, which is going to be our entry point, and it's going to be our orchestrator for this bronze layer. And then we are going to have an empty init.py file, which is going to help classify this folder a package. So let's create the files for the bronze. So here I'll create a new file and name it bronze schema.py. So this is going to hold our schema validation logic. So this is a module, and then we are going to need another one. We're going to call it bronze properties.py. So this is going to hold our autoloader logic, and then we are going to have another. We're going to name it main.ipymb. So this is going to be a notebook, and this is going to be our entry points, basically chaining our bronze logics. And then we are going to make it a package by having our init.py module. So we can leave this one empty just to make sure that when we are referencing a bronze from outside this particular layer, it's going to recognize it as a package. So that is the essence of the init.py. So where do we start from here to populate our files? We are going to start from the schema validation here. So I'm going to take the logic and explain everything about it. Here we're going to start by importing the struct type and struct field, string type, integer type, double type, boolean type, array type, all this from the PySpark, because we are going to be having basically JSON objects in terms of our raw data. And in this bronze layer, we are going to be preserving our raw data in their original format, basically in their native format, with no transformation or no flattening involved. So before I go further with this, let me show you the structure of the raw data. This is the structure of the raw data. So as you can see here, we have different JSON objects, and in some cases there are some nested JSON objects, like as you can see here in rooms. We have a nested JSON object here. We have the rooms. Under the rooms, we have the bedroom, bathroom, and then the total rooms. And then features as well. It's another nested JSON object. Then we have here array. Transaction history is an array. Here we have a nested JSON object in it, and then we also have other data within it as well. And then we have market trends here. This is another nested JSON object. This is another one as well. So this is the structure of our raw data, and then in bronze layer we're going to be preserving this same structure because we don't want to apply any transformation, and we don't want to flatten it because this is going to be our single source of truth. So we are going to retain the original format of the data. So the flattening and then transformation is going to happen in the silver layer, but for the bronze layer we're going to preserve this. And to do this, we are going to also define the schema validation rules, which will basically take this same structure without applying any transformation. So that's the next thing we are supposed to do within the bronze schema here. So let's add this. So this schema validation logic is basically telling Spark, because we are using Spark here, what type of data to expect, and what are the data types for each of these values, what are the data types that we are supposed to expect from them. And then we have the struct type, and then we have the struct field. So struct type is used to define a value in PySpark. So we want to define a value, and then like in this case, we have struct field is used to define a value, not struct type. Want to define a value, and then in this case we want to give it the data type, and also if the value is nullable or not. If it's nullable, then we say true. If it's not nullable, then we say false. So basically a boolean value should be given here, either true or false. So for instance, this struct field is used to define this property ID, and we are saying that property ID should be a string type, data type, and then we are saying that it's nullable. Yes, it can be null. And then we have for struct type. Struct type is used to define a JSON object, which is like the nested JSON object, like I showed you before in the raw data. As you can see here, you can see, for instance, address is nested JSON object. So here we are going to first define it with a struct type, and then we'll now define each field with a struct field. So which is what we are doing here. You can see address struct type, showing that it's a nested JSON object. We have other objects inside, and then the struct field is for individual value within the nested JSON object. So here we are defining the struct field again. Street should be string type, and it's nullable and all that. So anywhere you see struct field, it simply means that we are defining a particular value, and for struct type simply means that we want to go into a nested JSON object. So the same thing is happening here. You can see here we have the struct field, and then we are going to the nested object individually, so using the struct field. And then there's another one here. We can see here we have array type. Array type simply means we have different nested JSON objects within this transaction history. So array type, and within the array type we have the struct type, and then we'll now define the individual struct field for the individual values within this array. So we'll have the transaction ID is going to be string type. So basically we are enforcing the schema validation here. So any data that doesn't pass this validation is not going to go into our into our data pipeline. Basically it will be rejected, and it will go into our quarantine table based on our initial discussion. So this is our schema validation module, and it's important that we define this separately because there might be a case where this particular schema validation might be needed for other tasks. So in that case, we don't have to go individually to those tasks and start defining them. Ordinarily, we could easily use this inside our bronze properties module, but we need to keep it as a module of its own because we can need it somewhere else that has nothing to do with the bronze property module. So maybe we are working as a team and other team members need to also do the same validation. We don't have to also rewrite this whole logic. All you need to do is to import this module into that particular place where you need to use them. So that is why we have this as a separate module within the bronze layer. So the next thing we are going to do is to also work on the autoloader, which is we contain in this bronze properties.py. So the next file we are going to create, we already created, is the bronze properties.py, which is going to be the autoloader file or module. And then let me paste this and then I'll discuss it. So here we have the logic for the autoloader and have it within the bronze processor class. And starting from here, we are saying from pyspark.sql import spark session and then the data frame. And then from bronze schema, we are importing the bronze schema and bronze property schema, which we just created here. You can see we are importing the bronze property schema. So now we are using the absolute import here because both files, both the bronze properties.py and the bronze schema.py, they all belongs to the same parent package, which is the bronze. So it's okay to use a absolute import in this case. We will say from bronze schema import bronze property schema. So now we have the class, bronze processor class, and then we have within class we can have different methods, and class is like a blueprint of what we want to do. And in this case, the bronze processor class, its job is basically to read data from our Google Cloud storage. That is what it's supposed to do using autoloader. So in order to do this, it requires some parameters, and then that is what we are defining here within this init method. This init method basically saves those parameters within the bronze processor once we created the bronze processor object. but we are only going to create the object within our main file, not here. We're only defining it here. So here we have the arguments that we are going to pass at the end of the day. We have the Spark session. Of course, we need this to initialize the Spark session to be able to run whatever we're going to run here. We need the Google Cloud Storage path, which basically point us to where our raw data is in Google Cloud Storage. And then we need the target schema and then DBT utilities. Basically, all the necessary tools that are needed by Databricks to actually run this module. So here we are going to save all this. At the end of the day, we're going to pass the parameters for this argument, and then whatever values is being passed here will be saved within the bronze processor object once we create it. That's why it said self.spark, self.google cloud storage path, and then self.target schema, self.dbt db utils. So this self is what you are going to use as a parameter here for this ingest raw data property. And once we do this, basically all the arguments or parameters that we have saved within the self or bronze processor object will be applied within this autoloader part. So that is what this init method is supposed to do. Basically, take all the arguments, pass the parameters for the arguments, and then save them within the bronze processor object, and then use them wherever they are needed within any method within the bronze processor class. So the next thing is our ingestion of a raw property. This is our autoloader. So let's discuss the ingestion raw property data method. So here we have spark.readstream, and then we are saying that the format should be cloud file. This basically tells you that this is an autoloader, and then we are reading files from a location in Google Cloud Storage in this particular case. And then we have these several options. We are saying cloud file.format is JSON. Of course, I've shown you the structure of our raw data. It's in JSON format. And then option of multi-line is true because we have some nested JSON object as well, which I've shown you already. And then we have cloud file.include existing files is equal to true. Yes, we are asking it to also read old files within the bucket, not just the new ones. And then we are saying that cloud file.schema location. Now, this is where we are going to save our schema that we created in the previous, our schema validation that we created in the other module. We are going to save it within this particular part. And then we are saying that cloud file.validate option is equal to true. Then this basically tells us that every option that we are going to use here should be valid. And then we are saying that cloud file.use notification is equal to false, and then cloud file.use incremental listing is equal to true. So incremental listing, basically this is going to be an incremental pipeline, or it will only process a new arriving data and not refresh the whole data pipeline each time a new data arrives. So it only process the new one. And then we are saying that the schema here now is going to be our bronze property schema, which we created in the bronze schema.py, which we also imported here. So this is what you are going to use. Instead of writing the whole thing here, we only just import this particular function, and then we use it within this autoloader. And then we are given the parts where the raw data is, which is .load using this particular Google Cloud storage part. This is what you're going to provide when we try to create the bronze processor object. So that is what the autoload is all about. So the next is going to be the main.ipymb, which is the main notebook. So let's create the content of the main notebook in this case. Let's add a code. Let me select a kernel, Python environment. So now this is where we basically create our bronze processor object. As you can see here, just like calling a function, but in this case, you can say we are calling the class. And in order to do that, we have to pass in the parameters for the arguments that are supposed to be within the class, which we are going to save in the init method. So in this case, those arguments we haven't defined, and we have to define them before actually call the bronze processor object. And here we have a Spark. So here we are going to create our Spark session and then save it within this Spark variable. And then for Google Cloud storage part, we have this, and this parts, we are saying that spark.databricks.bundle.variable.data bucket, because we don't want to hard code the part. Because of that, we have to save it within our databricks.yaml file, which is our configuration file, and basically call the variable here and then use the part here. So there are two things that are within the variable. We are going to show that later in our databricks.yaml file: the data bucket and then the Google Cloud Storage prefix. So these are both saved in our bundle. That is why you have spark.databricks.bundle.variable.data bucket and then Google Cloud Storage prefix here. We are going to show that later. And then the storage part now is basically the combination of both of them, so which is what we did here. So this will now give us the Google Cloud Storage part variable. And then we have to now call or create our bronze processor object. So that we are saying here, bronze processor is equal to bronze processor object, which we can see in our previous code here. You can see that here. These are the arguments. So these arguments are what we just defined. And then we are now passing them as parameters to be able to create the bronze processor object. So this part, what this part is doing, we are importing DLT, but in a case where we are not running this within Databricks environment, then we are going to have import error, because this DLT module is specifically for Databricks, which help us basically create our declarative, which basically convert functions to table names. That is what it's supposed to do. But what if we are running it outside Databricks? We don't want this import error to break our logic. So we have to use try and accept here. And in this case, we are going to now mimic another DLT class here, which we are creating here. Then we are going to say the def table, which is the table method, and then the decorator method. So basically mimicking what we are supposed to do here, dlt.table. So that is what this is all about. If we are running it outside of Databricks environment, we don't want it to break our logic and then break the pipeline running. So basically, we have to try and accept here. But what we are trying to do mostly here is to import our DLT, and then we use the DLT decorator here .table to create a table for this our bronze layer. And then this function here, def BRO properties. BRO is basically a preface for a bronze. When we go into our Unity catalog, anything that has BRO is basically our raw data, which means bronze. And then anything that has SI is going to be our silver data, which means transformed. And then anything that has gold preface is going to be our gold layer. So in this case, BR properties is going to be our table name within our Unity catalog. And then here is where we are basically calling the method within this particular class. The method here is our autoloader part, which is let me show you again, which is this particular method, the ingest raw data property. So we are now calling this like we are calling the function using our bronze processor object. So that's what we are doing here. So using this bronze processor object, because this bronze processor now we have created it now has the Spark, the Google Cloud Storage part, and the DBT utils. It contains all this now. So we are now using it to now call the method, this particular method, which is what we mostly need. And then we are now returning a DF. So this BR properties is going to contain the raw data in their original format as they are, without being modified at all, because from our bronze schema.py, it shows that we retain the original or native format of our raw data. So that is what we have here for the bronze layer, basically. So the next thing is going to be the silver layer. So now we are done with the bronze layer. Let's go to the silver layer. So for the silver layer, we are going to be needing several files. Just like the bronze layer, we are going to be needing the silver schema.py, which is going to contain the flattening valley schema. So here we are going to create a new file. We'll name it silver schema.py, and then we are going to need another file. We'll name it silver validation.py. So this silver validation will basically give our validation rules for the data that we are going to consider as acceptable data and the ones that won't be accepted. So the unacceptable data, the invalid data, so they will basically go into the quarantine table, while the valid data will basically pass through the pipeline. So we are going to have another, which is going to be the main transformation logic for silver. So we are going to name it silver properties.py. And then we are going to have the main orchestration notebook for this server layer. We're going to name it main.ipymb, which is a notebook basically. And then we are going to configure this server layer to be a package by adding the empty init.py file. So these are the files that will be contained within our server layer. So let's populate each file, starting with the server schema, where we are going to define our schema for our transformation logic. In this case, the schema will be transformed, not unlike in the bronze layer where we retain the original format of the data. So let's start with the server schema. Let me page this so we discuss it. So here we are importing from PySpark.sql. We are importing f, which is basically a function as f, and then we are also importing a data frame from the same PySpark.sql. And here we are creating the property schema class. This is for the server now, and then this is basically a class where we are going to flatten our nested JSON objects. And here we are going to have static method. This static method is basically saying that we can just import this flatten property data method directly without initially creating the property schema object. So we don't need to instantiate the property schema. We can just directly import this property flatten property data method. So that is what the static method decorator is being used for. So here we have the top level fields and the nested fields. For the nested fields, we are using column functions to actually extract them. And for the top level field, we are just selecting them directly. As you can see here, we are saying dataframe.select. Here for this nested field, we are using the main field name address.street, address.postal code, address.bureau, and we are using these layers from the same function to give them their names. So here we have the top level fields. We just import them, select them directly, and then anywhere you see function.column simply means that it's a nested field. And then there are other places like here we have an array, so we have to explode the array, especially in this transaction history. Let's go back here and see it. Transaction history, you can see that it's an array, so we have to explode it. So that is what we did here. After exploding, then we can now select the fields using the column function, and then using alias to actually give them the names we are going to use for these particular fields. So that is what this schema validation module is doing for the server. Now we are trying to flatten the JSON object, which is our raw data. So in this particular case, in server, we flatten the raw data. So that is what this does, and we are created a module for it separately because the same reason I gave why creating the module for bronze layer for bronze schema is the same reason we are also creating this, because it can be reused everywhere else they are needed. So now we go into the next, which is the server validation. This is for the server validation. This import as before, and we are also importing the Spark session here, and then we are creating the server validation class. And within this class, we are creating the init method here to basically save our Spark session within the server validator class. And then we have another method which is valid and the quarantine. Here we are giving the conditions of what should be considered a valid data and what should be considered as invalid data. So, and then for the ones that are considered valid, they're going to pass them through our data pipeline. The ones that are considered invalid are going to go to the quarantine. But this module is basically to define what is valid and what is not valid, and they attach reason for why a record is considered invalid. That is what the server validation module is doing. So for this particular validate and quarantine method, we are basically giving the conditions here, and we are saying that it's considered invalid, which this is invalid condition if the construction year is null. So if it's empty, we are consider it invalid, or if the construction year is less than 1960. So in this case, if the building construction year is less than 1960, this is just for demonstration purpose. Ordinarily, that shouldn't be an invalid. That shouldn't be a reason for making a data invalid. So, but for this project, we are saying that if the record is less than, if the construction year is less than 1960, then we are considering it as invalid. And if the construction year is greater than the current year, which simply means building is being constructed in the future, we are also considering it is as invalid. And also, if the sales value is null, then if the sales value is less than 0, then it's also invalid. Then another reason is if the price per square meter is null or the price per square meter is less than 0, which is simply means it's a negative, then we are considering it as invalid. And if the property ID is also null, then it's invalid. And then if the size per square meter, which is the size of the property, is less than 0, then it's also regarded as invalid. So this is the invalid condition, and we are saying that invalid df now, which we are defining here, is equals to the df.filter invalid condition, and then we are adding this column is quarantine is either true or false, but in this case we are saying that is quarantine is equal to true. Then if it's not invalid, then it becomes valid. That is what we are doing here. This simply means that for valid df, we are saying that df.filter not invalid. So anyone that is not invalid is actually valid. So that's what we are doing here. So here is where we are attaching the quarantine reason, and we are saying that if the construction year is missing, then we are saying missing construction year. If the construction year is less than 1960, we are saying construction year is too old. So basically attaching values to the reasons, these particular conditions. And then here for this particular validate and quarantine record, we are returning both valid and invalid. And for the invalid, we are now attaching the column quarantine reason, which we just created here. So we are attaching this column to the ones that are invalid. So that is what this script is all about. And we created a different module for it as well. So the next is the Silver properties, and the Silver properties contains the blueprints for creating the Silver layer. So here we have the Silver processor class, and first we are going to use absolute import to import the Silver validator from our Silver validation module, which we just created, and also import our property schema as well from our Silver schema module, which is also here. So we are going to use this here because this is basically our module that's going to create our Silver layer kind of property. So here we have the Silver processor class, and then within this class we are going to have different methods logically. And the first method is going to be the init method, which basically save the Silver bronze table, the spark, and then the Silver validator within the Silver processor class. So because for Silver layer, there's going to be a logical flow of data from the bronze raw data to the Silver layer. So basically, we are going to need a bronze table here as one of the arguments, and it's going to be one of the parameters we are going to pass when creating the Silver processor class object. So the other method is going to be the flatten property data method, because we already have within the property schema class, we already have the flatten property method, which we showed earlier from the Silver schema here. We have this property schema class, and then we'll have the flatten property method. So this method is supposed to flatten the data first of all, because like I said, we are importing the raw data from the bronze layer, and then the first thing we are going to do is to flatten the raw data, which is what this method is doing. And in order to do that, we are not going to write the whole Silver schema logic here to basically populate the whole of this place. We just want the code to be a bit neater. So we're just going to import the property schema class, which we are going to instantiate here. And then we return property schema.flatten property data method. And then the DEF. The DEF here is going to be the bronze property. That's going to be the DEF. So the first thing to do is to flatten the data. Then the next thing to do after flattening data is to process the data. Processing data in this case is basically getting the valid and the invalid records. So that is what we're going to do with the processed data. And that we also did here as well in the Silver validation.py. So here we have flatten data is equal to self.flatten property, which is this now, and then we are now taking this flatten data, and then we are now trying to get the valid DF and the invalid DF by basically using the validator. The validator here is from this Silver validation, and then we are saying that from the validator we are going to use the validator and quarantine method. So let's check again. So we have the silver validator, and we are saying that we are going to use the validate quarantine method, which this is the method. Remember, we created the validator here when we use the silver validator class. So here we use the Spark as our parameter. So that is where we created this validator variable. It's the same thing as using the silver class to actually call this validator and quarantine method. So here we will now pass the flatten D into it. So what this does basically, from what we have seen here from the validator logic, from what we have seen, it returns both valid and invalid DF. So if you go back, so we are now saying that valid and invalid DF, basically calling this method validate and quarantine, and then we'll now pass this flatten D into it as the parameter, and then it process it. After processing it, it will now return the valid and the invalid record. So first we import the bronze, flatten the bronze, and then process the bronze to return the valid and invalid. And then from the valid, we are going to return the fact and the dimension tables within this silver layer. These are the tables you are going to have in the silver layer. So the fact and the dimension table. So the fact table here, we are basically selecting the transactional records from the fact table. So these are the records that are constantly changing. And we have the property ID, which is in this particular case like a foreign key. And then we have transaction ID here, which is the primary key. So this transaction ID will always be unique because for each transaction, it comes with a transaction ID. And then we have the sales price and the transaction date. So these are the frequently changing dimensions or frequently changing records. So we go into the fact table, and then we have the dimension table. In this case, we have the property transform property dimension. So the dimension table are the records that are not changing frequently, and they add contents to each property ID. So like here we have property ID, we have the street. The street doesn't change. Wherever a property is located, it's always there. So the street's name will not change. Postal code is not going to change. Bureau, latitude, longitude, these are the values that will hardly change over time. So those are now going to the property transform property dimension. So these are the two tables you're going to create within this silver layer. So you can see that within this silver processor class, these methods coming in logically. First flatten, second first get the data, then flatten it, process the data to return valid and invalid. From the valid, we get the transform transaction fact. From the valid also, we get the transform property dimension. And then also the invalid will be go to the quarantine. So the next is going to be the main.ipymb. So for the silver main notebook, we are going to, again, because they are siblings within the silver package, we are going to use absolute import here. Silver properties, we are importing silver processor class. So and also we are creating the Spark session and then the bronze table, because in order to create this silver processor object, we need some parameters that we have to use to fill in for the arguments that are needed. So we need the Spark and we need the bronze table. And now the bronze table here is our BR properties that we created. By default, DLT will recognize these BR properties because they are within the same pipeline. So it's going to recognize this. We created these BR properties within our bronze layer. If you come down here, you see we created this. So this is what is holding our raw data. So we are going to need to pass it as an argument, as an argument within this silver processor object. So while creating it, we need to pass this. So we define it here and we define the Spark, and then we create the silver processor object. So now we come down here using our DLT decorator. We are going to define a table. We are going to give comment here. We are saying that the table is going to be quarantine record for this particular one, quarantine record for silver. Then the table properties, the quality of the table property is going to be silver, and then the partition column is quarantine. So here we have def, this function def si quarantine records. This is going to be the name of the quarantine table within our Unity catalog. So we have def si, it has silver quality, and then quarantine records simply means that the records that are invalid will go down here, because we need to also inspect them to see the reason why they are invalid, and then maybe take care of the problem from the source. So here we are saying that bronze df is equal to dlt.readStream Each stream in this case is going to help us maintain our lineage graph to show where the data is coming from and where data is going if possible. So here we have a DLT.read stream. We are reading from the bronze table now, and then we are now using the invalid. We are now needing the invalid record. We are saying that silver processor.process data. Now, silver processor is basically our from our silver object, which basically processes our silver processor class. And then we are now passing the bronze df, which is this raw data we just created here, as our parameter here. So once it processes this, once the silver processor method processes this, it will now return the invalid and we are dropping duplicates. So that is what this does. And then again, we are creating another DLT table. In this case, we are saying that the comment is transaction fact table and the quality of data is silver. So here is the table name using this function, SI fact transaction. SI simply means it has silver quality. And then again, we are reading from the bronze table, and then we are now only interested in the valid D in this particular case. So we are now selecting from the valid DF. So we are now saying that silver processor dot process the bronze DF, and then we are now saying from silver processor dot transform. The silver processor now is the silver object, and we're now using the transform transaction fact method. Let's go back and see it. I know it's a bit confusing, but just bear with me. So here we we have a transform transaction fact. This is the method we are now using to basically select these features from our valid data. So that is what we are doing here. So now saying silver processor, this is the class the object we just created from the class. And then from this particular one, we are now calling this function basically. So this function now is the method transform transaction fact, using the valid df only. So it's going to select those records from only the valid df, ignoring the invalid df, because the invalid is going to the quarantine table. So we'll do the same thing for dimension, exactly the same thing, but in this case, we are using the transform property dimension method to select from the valid df as well, also dropping duplicates. So this will create this SI dimension properties table, SI fact transaction table, and also the SI quarantine table. So within the silver layer in our Unity catalog, we are going to have these three tables. So basically that is that for the silver layer. So now let's go to gold. We are done with bronze and silver. So let's create the files that are required for gold. And then for gold, we are going to need the gold properties module. So come down here and create a new file. So this gold properties of py, we're going to need it. And then we're also going to need the corresponding main.pynb for the gold. Then we are going to need the init file to make the gold a package. So for the gold properties of py, we're going to have this. Again, we are going to import iSpark functions as f, and we are going to import our Spark session on our data frame. And then we are going to create the good processor class. Within this good processor class, just like before, we are going to have the init method where we are going to save the Spark section, which are going to reuse in the different methods we have here. And then we are going to create two methods. One is the aggregate property evaluation. So basically, gold contains the aggregated data, which we are going to use for reporting at the end of the day. And here we want to have one method, which is aggregate property evaluations. And here we are going to be needing, we are going to be reading from two silver tables, one the fact and the other dimension table. And then this method is going to accept fact table as an argument, which is a data frame. It's going to accept dimension table also as an argument, and then this cell. And then here we're going to perform join between the dimension and fact table. We're going to perform an inner join using the property ID as the common feature here. And then we are going to group by the borrow. So the borrow in this case, we are going to get the evaluation of the property for each borrow. That's what we're trying to get. And then we are going to get the average sale price in euros, which is going to be average sale price. And then we are also going to get the average transaction price per square meter, which is going to be the average transaction price. So this is what you are going to return at the end of the day for this aggregated property evaluation for each borrow. And then the second method is going to be the build neighborhood trends. And this is only going to come from the silver dimension table, as you can see from this argument. And then we are going to group by borrower as well. And then now here we're returning the medium income, average medium income. We are returning the average population density, the average crime rates per 1,000 residents, and the maximum average price per square meter for each borough. That's what you're going to return with this. So these are the aggregation you're going to perform within these two methods. So now we are going to populate main notebook. So here our main notebook, I've already explained this part previously. All you are using try and accept here. All we need here is the DLT import. So we are importing Spark session, and then we are using absolute import as well to import the good processor class from the good properties module, which is this. And then we are creating the Go processor object here by saying Go is equal to Go processor and then passing Spark as a parameter here. And we've already defined the Spark session here. So here again, we are using a DLT decorator to create a table. The comment is aggregated the property evaluation in good layer. And you can see in this particular case, quality is equal to gold. So here we are defining the table name, which is the function here, Go property evaluation. And then we are reading from two silver tables, SI fact transaction and SI dimension properties. So in this case, DLT will automatically detect these tables because they are within the same pipeline. So this SI fact transaction and SI dimension are the fact and dimension tables we created within the silver layer. So you can see SI here stand for silver. So we are ready from these two tables, and then we are now passing these two tables as the parameters for this particular aggregate property evaluation method, which is within the Go class. So this is what we are returning here. But here we are using dlt.read, unlike in the previous case in Silver, where we used dlt.read stream. If you come down here, you see we use dlt.read stream here. This basically is incremental by default, and it's basically read the arriving date in real time. But because in Gold we are aggregating, we can't use dlt.read stream in this case. If we want to use dlt.read stream, that means we have to give the windows period where the aggregation is going to take when the aggregation is going to take place. But in this case, we are using dlt.read because it's a good layer, and it's basically like a badge stream or badge read in this particular case. And then since it's an aggregated or business logic data, we don't really need it to be in real time. But if you want to make it real time, it's almost technically not going to be in real time, because at the end of the day, you have to provide a window of aggregation you want. If it's every 5 minutes, you aggregate. If it's every 20 minutes, you aggregate. That is the only time you can use a dlt.read stream. So, but in this case, it's a batch read. It's not going to be like real time. If we want our reports to be in real time, then we have to connect our BI tool, for instance, to our Silver tables instead of our Gold table. So that is why we are using dlt.read here instead of dlt.read stream we used in our Silver layer. So again, we are doing the same thing for the Go neighborhood trend. Here we're only using the SI dimension properties, just one silver table here to perform this aggregation, which we showed in our good properties.py module. So this is what the good is all about. And then the next thing now is going to be to write our jobs. So jobs is going to be the next thing we are going to create. Here we are done with the pipeline because we are done with the gold, bronze, and then we're done with the silver. So the next thing is going to be the job, because within this Databricks Asset Bundle, we are not only going to deploy our data pipeline, we are also going to deploy our jobs that are basically perhaps being created from the tables we have already created now. So now we are creating different jobs. Maybe data analyst has some jobs, analytical jobs that he or she has already created, and then want to also deploy it through the Databricks Asset Bundle. So We assume that is the case, so we are going to create additional job to which we are also going to deploy within this pipe. So now we are done with the code layer, and we need to discuss what we have in the main configuration file. Here we have databricks.yaml, which is the main configuration file, which must be within the root folder of the project. And then we are going to discuss the pipeline configuration file as well. So, but first let's discuss the databricks.yaml file. Here we have this. When we initialize this Databricks Asset Bundle, these were automatically created based on the parameters we used for the initialization, and we authenticated using the host development host URL, and also we used the production host URL. So these two were also created, but the variables I just added. Now here the variables, because we are going to configure our Google Cloud storage buckets, and then we are going to configure them as variables within this our main configuration file, because at the end of the day we don't want a situation whereby we are going to hard code the storage parts anywhere else apart from within the configuration file, and each environment has to have its own configuration. So as you can see here, by default our target environment is development, so which you can see default is true, and then we gave the host URL here, the workspace host URL, and then these variables, now we are saying that the data bucket is going to be within this real estate data dev bucket, and then the file part now within this bucket is going to be within this part development slash raw slash properties slash the year. We are using the year of 2025 record. Now the catalog is our Unity catalog. For development, our Unity catalog is going to be named real estate dev, and then our schema for this pipeline is going to be named pipeline dev, and then the job schema for this environment is going to be named real estate jobs dev. That's within our Unity catalog as well. And then for this variable, the mode is going to be development. Then we're doing similar thing for the production workspace, and we are doing the same thing here. But in this case, our data bucket is going to be our real estate data production, and then because the production bucket contains the full data, while the development bucket contains just a few number of records. So of course for development we don't want to use the whole data. So that means if we are deploying to production and our target is production, then we are expecting our pipeline to take its raw data from the production bucket within our Google Cloud storage. But if you are deploying to development, or maybe you are testing and deploying to development, we are expecting to take it raw data from the development bucket. And then the schema for the Unity catalog is going to be pipeline production, and the catalog for our production workspace is going to be real estate and production. So the job schema is going to be real estate job production, which we are going to create manually. And then the mode again is production. So let's take a look at these buckets within our Google Cloud platform. Google Cloud platform. Let's look for storage, cloud storage, then go to buckets. So you can see here within the buckets we have a real estate dev, data dev, and we have real estate data prod. So this is for the development, while this is for our production. And then these other buckets were created by default when we were creating our Databricks platform. So these were created by default, and so these are the places where our data, which we are going to be creating within our Unity catalog, will be stored. Because, like I said at the beginning of this, I said that our data are not usually stored in Databricks because Databricks doesn't store data. Basically, what they do is they use Unity catalog to store the metadata of our tables, the file locations, and these are the file locations. So whenever we query any table within our Unity catalog, Unity database comes down here to fetch the record and then give us the result for whatever query we are carrying out. So this is where we have our files being saved, our records being saved, our data being saved, everything is being saved here. And then this is the one we created by ourselves, where we have our raw data. So that is that for our Databricks configuration file, the main configuration file. And then let's take a look at our pipeline configuration file, because since we have created our bronze, silver, and gold layers, so it's appropriate for us to take a look at our pipeline configuration files, which is usually located within the resources folder. So we have the job configuration file and have the pipeline configuration file. So let's take a look at this. So here we have the resource pipeline, and then we have the real estate pipeline, which is the name of this resource, and then we have the name, which is this, and then we have the catalog. Now the catalog is here. We are making it dynamic here because we don't want to hard code anything here. So we have already created this within the variables in our main configuration file here. So all we are doing here is basically saying that variable.catalog will give you the catalog name here. So let's just check. You can see here we created a catalog, real estate dev, schema, pipeline dev. So the reason we don't want to hard code it here because it depends on the environment you are deploying to. So if we are deploying to production environment, it doesn't matter. If we are deploying to development environment, it doesn't matter since we are making it dynamic here. So the environment you are targeting at the end of the day has any environment you target has this catalog and schema also defined within our databricks.yaml file. So that's why we're making it dynamic here. Because at the end of the day, we just want to develop this whole asset bundle once, and then we're able to deploy to all the various workspaces that we have. So here we have the cluster configuration. We are not using serverless here. We're using the classic serverless configuration. We are setting the auto scale. Auto scaling here simply means that we want it to. Here I'm using the minimal configuration because I don't want to incur much cost because it's just for demo purpose. So I'm saying that the minimum worker here is 1, the maximum worker 2, and then the node type here is basically a kind of virtual machine that our Google Cloud platform is going to use to run this configuration is this, and then we have availability period as this, and then the zone ID as this, and the Google service account as this. Now, without this Google service account, we won't be able to have access to our bucket, our raw data in Google Cloud Storage. So we need to create a service account with which we can be able to, have access to our raw data in a Google Cloud Storage. So this is the email address attached to our service account. So that email address is what we are going to give as the value for this Google service account here. I'm still going to show you that in Google Cloud Platform. But first, I need to explain something here. This configuration is being provided by Databricks. Just like, having a software and then you need a hardware to actually run your application. And then in this case, Databricks provide all the software configurations, but we need a machine to basically help us run that application. And then that is basically what this is about. Here now, this is the machine configuration we're talking about. This comes from Google Cloud to the platform. So this machine, virtual machine now, will basically help us run this cluster and then spin up our Spark cluster, which is this for whatever workload you are going to carry out. So in this case, if the workload is high, we are saying that you should go assign a maximum of 2 workers. And if the workload is low, you can scale down to 1 worker. Because our workload here is small, so basically are able to handle this particular workload using just a maximum of 2 workers. But that is usually not the case when you come to a proper production. Let me explain this part. Here, these are the notebooks, the main entry point notebooks we are going to be running within this resource, this pipeline resource. And we are going to have the first notebook, which is the bronze, because this data is supposed to flow from the bronze. And then the second notebook is the silver. It flows to the silver and then flows to the gold. So here we are using relative part, and here we are saying that you should step 1 up once. You're going to get the source, and within the source you're going to see the pipeline, and then the bronze, and then the main.ipyimb. So which is the same thing as here. Within source we have pipeline, and within pipeline we have a bronze, for instance, and then we'll find the main notebook for it. So that is what we are doing in this particular part. And this configuration part, we are saying that from the Databricks. So in the additional configuration, we have the part for which we are making dynamic, the part for the data bucket, the Google Cloud Storage preface, catalog, schema. We are taking this from the variables which we already created within the databricks.yaml file here. This is the variables we created. So these are the variables, and this is where we define them and give in their description. So for the Databricks main configuration file, this include here is going to contain all our resources. So we are now saying that for the first one, we are saying that every .yaml file within these resources, we want you to consider it, or want you to consider, wants to consider every .yaml file within these resources. And here, this in our case might not be valid because we don't really need this part, but let me just leave it. But what we need is basically because our .yaml file is not within any folder in the resources, it's directly within the resources. So the first one is valid for our files here. So these are all the resources that we are going to consider within this main configuration file. This pipeline resource here, and for this Google service account, after creating your service account within Google Cloud Platform, that service account, you're going to give it storage admin permission. That storage admin will basically give you access to read and write from your storage buckets, so which is what you're attaching to this service account. And then from the service account, go to the client, generate a key, service account key, and then from there, open it, and then look for the client email. The client email is what you are going to attach here. Just copy the client email only, and then attach it here. So this will give your pipeline the right to read from your Google storage, from your Google Cloud storage, which is basically your data lake. So that is what we are doing here. So now let's create our jobs. We are going to have two different tasks that we're going to have inside our jobs. So those tasks we are also going to deploy alongside the pipeline that we have just created. So instead of deploying the pipeline alone, so let's just create the jobs now and then deploy everything at once. So within the job, we are going to create another folder. We're going to name it task. So within this task folder, we're going to create our init file, and then we're going to create our file for our first task. So we're going to call it neighborhood insight report, and then we're going to create file for our next task. We'll call it a property violation update. So, and then we're going to add our init to our job folder. So now let's populate these files. These are the tasks these two tasks we are going to have. So let's populate them. So before explaining our tasks, the two tasks and the tasks we are going to create here, let's first explain this our job configuration file. Here we have the job name as real estate jobs, and then we have the trigger. We want it to run periodically once every day. So, and then on failure, we want it to send a notification to this particular email. And then the task, now we have the first task, neighborhood insight report, which comes from this file. And then we'll have the second task, property violation, which comes from this second file. And then we'll have the notebook task, and we'll give it notebook path using the absolute path, using the relative path. So we have, this is the path to the notebook, which is this. And then we have the base parameters. So the base parameters here is going to tell us where the catalog is going to be, and basically what is going to be the name of the catalog, and the name of the schema, and then the job schema. Catalog in this case is our Unity catalog, and then the schema here is the schema, and then the job schema. The job schema is where we are going to save our job tables at the end of the day. And then the same thing for this, but here again we are still making it dynamic because it's fetching this value from our databricks.yaml file here, which are the ones we have already defined within each environment, each target environment. Here we have dev, we defined all those catalog schema and job schema as well. Job schema here for dev is named real estate job dev, while the job schema for the production is named real estate jobs prod. So this is where this job resource is taking this configuration from. So from the variable, we are reading from the variable.catalog, variable.schema, and then variable.jobs schema. So these are the base parameters for this. And as you can see here, we didn't configure any cluster. Within the cluster configuration is kind of missing. The reason for this being that you are using a serverless. Serverless is being provisioned by Databricks themselves. And that means we don't have to, by ourselves, configure what, for instance, the maximum or minimum number of workers should be, and then the kind of virtual machine we are going to use from our cloud providers. So Databricks are handling that. So once you skip the part of the cluster configuration, it's assumed that you want to use serverless. So because of that, we are using serverless here. We are not basically configuring for the cluster. So the cluster here is missing because we are using serverless. So if you want to use classic cluster, then we have to configure it manually. But because we are not configuring any cluster here, that simply means by default we are using serverless for this particular job, for the jobs. So we are going to see all this when we deploy, see how the serverless compute is going to start up immediately. And then now let's go into the jobs notebooks themselves. So we have the first one, notebook insight report. As you can see here, we are using a widget to fetch this catalog schema and job that we already defined within our base parameters. Here you see the base parameters. So this is what these widgets are fetching. So the widget is fetching the catalog schema and the job schema from the base parameters we define within the resource of the jobs. And then basically, so everything here is dynamic. We don't have to put everything hard coded here. So it's dynamic. It's based on what is happening in the Databricks.yaml file. You can see that this is referencing the resource, job resource, and job resource is referencing the Databricks.yaml file. So everything is kind of connected. And then here is the logic for the neighborhood insight report. We have here the trend table here is basically our catalog.schema.go neighborhood trend. Simply means they are taking our data for this particular task from our gold table, because you can see go neighborhood trend. So we are now using dlt.read this time, or dlt.read stream, because this is just a task that we are trying to perform. So it's not going to maintain the same lineage that our pipeline is going to maintain. So it's not part of our pipeline. It's just a task that is dependent on our pipeline. So we have the trend table here, and then we have report table, which is job schema.neighborhood insight report. So this is where it will be saved, and this is where it will take its data. So this is the source and this is the destination. So here we have a class, the insight report processor class, and within it we have the executor, which is the init method, which is basically responsible for the Spark session and also accepting the trend table argument and the report table argument. So trend table here is the source table and the report table is the destination table. So here we have a generate neighborhood insight method. So this is just the logic, basically like what we did when we are performing our good, but in this case we just did a little bit more by adding the report mode. So we are grouping by borough and the report month, and we're getting the maximum of the average median income and the average population density. These are the two things we are getting here. And then we have another method which basically saves our record or our query into our destination table. So we have here the df.write format delta. So we are using the delta lake delta property for this as well. And then we are saying .mode append, so .save as table. So each time it runs, it gets the new insight and append it to what we already have. So that is what this is doing. So here we basically create our processor object, and then here we apply our Spark, and then here we use our processor now to call this our method generate neighborhood insights, and then we attach this trend df to it, and then the processor.save is basically we save the reports by append mode into our destination table. So that is what this does. And then the same thing basically applies here. I don't have to explain everything all over again. So everything I did in the neighborhood insight reports, basically the same step, the same process, just the logic that is different. And we also save and append to the destination table. So that is that for the job. Now that we are done with the job and we are done with the configuration files, I think it's now time to test our data pipeline. So now let's deploy our bundle and then also run the bundle. So let's open a new terminal. So now let's activate our virtual environment again. It's activated now. So let's deploy our bundle. In deploying our bundle to development environment, ordinarily by default, like as you can see here, you can see that our target environment is default true. So while deploying to target development environment, We don't really need to include the target dev. We can remove this part. We can just say Databricks bundle deploy. This will deploy to the target environment, to our dev environment, and which is our default environment. So it says Databricks, unable to locate Databricks. Okay, we are not in our root folder. So let's navigate to our root folder, which is real estate. So say cd real estate. So we are now in our root folder. So let's run it again. So we are getting end of file error because we didn't save our notebooks. We didn't save any of them. So now I have saved. So let's run it again. So now it's deploying, I think. So you can see uploading bundle file to workspace. Use this and this. It's loading. So you can see deploying resources, updating deployment state. So deployment complete. So it has deployed to our Databricks workspace, development workspace. So let's now run the deployment. So let's run the deployment now. We have Databricks bundle run, target environment dev. We can eliminate this if we want because our default, as I said before, is dev. So but let's just run this. So we are running the real estate pipeline here, which is this, waiting for resources. So let's go to, need to log in. So we have logged in now. Let's go to jobs and pipeline. So you can see both jobs. This is the job and this is the pipeline. Because we ran the pipeline, so you can see the pipeline is running. So at the moment it's still waiting for resources. So the same message you have locally is what we have here. The same message here, waiting for resources. So now created the updates and created the resources. And now it's initializing. From initializing, if everything goes well, then it's going to set up the tables and then render the lineage graph. That will be the last part, and let's wait and see what happens. Now we are the last part. As you can see it's creating the bronze properties. It has finished creating the bronze properties with 5,000 records. And then the next one now is dimension, the fat transaction. This is the bronze, this is the silver. This line is for the silver, and then this line is for the gold. So we have the SI fact transaction. So from now, it's populating the silver tables from the bronze properties. As you can see, the movement of data. They are moving to different silver tables. So let's just wait a bit. It's populating these tables. So once it's done populating these two tables, it will start flowing into the gold tables. As you can see, the gold tables are materialized view because what we did there was dlt.read, not dlt.read stream. So you can see these streaming tables because we used dlt.read streams. You can see these are streaming tables. This is streaming tables, but because we use dlt.read for here, for this particular gold tables, we have materialized view. So it's done populating the silver properties and silver facts, while the invalid record are going into the quarantine. So the valid record have passed to the silver, and from the silver they pass to the gold tables. So have good neighborhood and good property valuation. So you can see here we have the quarantine, SI quarantine record. So we have about 1,900 records that are quarantined because they are invalid based on our conditions, the conditions that we set. And then we have 8,000 records in the fact transaction table, and we have the 4,200 records in the dimension table, and then we have 20 records in the gold neighborhood because they are aggregated data, and we have under 20 record in the property valuation because they are also aggregated because we group them by bronze. So that's what we have here. So this is the lineage graph. We have seen the flow of data from bronze to silver and then from silver to gold. And then let's look at the catalog to see the tables themselves. So this is the catalog. Remember, the catalog name is a real estate dev. So within real estate dev, we have the pipeline dev. So this is where the tables are saved. So this pipeline dev is like the database of our development pipeline. So we have the bronze data, have the silver tables, and then we have the gold tables. So we can just preview this data. Let's click on any of them. Let's see the bronze sample data. We have to start the serverless, start and close. So it's coming up. So you can see the bronze data. You can see the address. Address is basically nested objects. You can see it. So each record has about 3 objects within it. And have the latitude, which is also a nested object. If you scroll down, go to the side, you see the orders as well. So you see the market trend nested object. So this is the bronze data, which is the raw data in its original file format. We haven't transformed it at this point. So this is our single source of truth. This is how they appear in our data lake. So, but now we have now applied the data lake ACID transaction on them, so we can basically carry out our Unity catalog advantages like placing our access control on top of them. And also here we have the silver. The silver here is basically the dimension. We have this, you can see it's a proper table data. It's already flattened, transformed. And then we have the fact, have the sample, the same thing. This is our fact. Then the gold table have a neighborhood trend. So you can see the neighborhood trend for each borough. We have the average medium income, the average population density, the average crime rate, and the maximum average price per square meter. So this the aggregation that we did for this. We only have 20 records for each of the boroughs. And then we have for property valuation, another aggregated record. We only have 20 records as well. So for each borough as well, we have the average sale price. We'll have the average price per square meter. So this is our good tables. These are our good tables. So we'll come back to this later on. But for now, let's go back to here. We have our real estate jobs. Let's also run our job and then see if everything goes on well. So let's run it. So click on it. It's coming up. So it has started running. So let's click on it to see the lineage as well. So you can see the first one is running, the neighborhood insight report. When this is done, this other one will run. We are going to have an error here because we are supposed to create the catalog manually within our Unity catalog. So we're supposed to create the schema manually within our Unity catalog. So let's go back. Like I said, we are going to have an error here because I didn't create the schema manually, so it's not going to find it. So you can see schema not found. The schema real estate dev, which is the catalog.real estate jobs dev, cannot be found. So how do we get the schema name? Just come down here, go to your databricks.yaml. You can see within the development environment, we defined it here, job schema. Unlike the pipeline that usually creates automatically, the jobs do not create the schema automatically. So you have to create it manually. So we'll copy this and then we'll go back. Then we'll go to catalog. So within our real estate dev, that's this, click on this and then we'll create schema. So just put the schema name here and you can add comment if you want, but just create. So now we have this schema here. So let's go back and then rerun the job. Let's run it again. So now it's going to create successfully because the schema is now present. So give it a few times. So now you can see that the jobs ran successfully, both of them, because we created the schema already. And then you can see the serverless automatically shut down after running the job because we configured it to use a serverless cluster. So you can see the serverless cluster here. And that is a good thing about serverless cluster. It starts up so quickly, and then once it's done with the job, it shuts down in order to save cost. So, and then let's go to our catalog. So this is the schema for our jobs. Let's refresh. So you can see the two tables here. So you can see the result, and then the violation updates, you can also see it. So basically, we have a schema for all the jobs we are going to be creating within the dev. We have a schema for the pipeline, which contains the bronze, silver, and gold tables. So in this case, we are done with development. We think everything is fine. So let's deploy to production to see if everything will work fine. So as you can see, we've confirmed that everything worked well within the development environment. We deployed our pipeline, it ran successfully. We deployed our jobs, they ran successfully. So let's now deploy to production. So like I said before, the essence of Databricks Asset Bundle is to basically develop once, be able to deploy to all the various workspaces that we have. But in this case, we define just two workspaces, the dev and the production. So we don't need to do any other thing within our code. All we need to do is to specify the command to develop, to deploy to production. So let's now deploy to production. So let me clear this. So Databricks Bundle deploy, target here is prod because we have prod here defined. So it's going to target these buckets for getting the raw data. Then it's going to create this catalog for the pipeline, and then going to create this manually for the jobs based on the configuration within this production in our databricks.yaml file. So let's deploy to prod. And to production, you can see deploying resources, updating deployment state, then deployment complete. So let's now run the production pipeline. So here we say Databricks bundle run. Target is production real estate pipeline. So that is what we are running now, just like we did within the development. So as you can see, we are deploying to production at the moment. So you can see waiting for resources, just like it did in development. And then workspace. So this is our Databricks production workspace. You can see it here, real estate prod. So this is our workspace. So you can see creating updates. Then now it's waiting for resources. So wait for this whole process to get through before coming back. So we are deploying to production. As you can see, it has finished initializing and it's setting up the tables at the moment. After this, it's going to render the graph. So let's wait a bit. So it's now rendering the lineage graph. Just the same thing we experienced in the development environment, we are going to see here in the production environment. But in this case, the volume of the record is going to be higher because you are not it's taking its source from the production Google Cloud Storage bucket. So here we have 15,000 records, unlike in development where we have 5,000 records for the bronze data. And you can see the data is now flowing to the SI dimension, SI fact, and quarantine table for the invalid records. So you can see here pipeline ID, the pipeline type is ETL pipeline. The source codes are basically where we can find the notebooks that contain those 3 layers codes. We have the bronze, we have the silver, and we have the gold. So the same thing, just everything that's happened within the dev, since the dev was okay, it's expected that the prod is going to be okay as well because it's still the same transformation that is going to take place here. The only difference is that the workspace is different and the source data is different, even though they have the same structure, but the source data location is quite different from the development data location. So that's why we have more records in the production environment, which is expected than we did in a development environment. So here we have 15,000 raw data within our bronze, and then the dimension properties, SI dimension property, which is the silver layer, we have the 13,000, we have 30,000 record, and then for the facts table, we have 24,000 records. In this case, the quarantine record is much, we have 6,000. And then for the gold table, which are materialized views, we have 2020 as well because it's still the same number of borrows that we had in dev that we still have in the production. So here we have streaming tables because we use the DLT.read stream. And then here we have materialized table because we use DLT.read for creating these tables. So let's see the record for this quarantine. Let's just go to catalog. Before we do that, let's run our job within the production environment. Let it be running while we discuss this. So catalog. So we have this. Let's see the quarantine table. Let's start up the serverless compute, start and close. So these are the invalid records. So remember, we added a reason for quarantining these records at the end. So let's go and see the reason. So you can see quarantine reason here. We have invalid or missing sale price for this. We have construction year too old. We have invalid or missing sale price for this as well. So here, for instance, we have a minus 46 euro per square meter. So this can be right, basically. And let's see, the reason is under the sales price per square meter here, which is the same as the sales price. The sales price is here. So you can see we have negative value, minus 8,460, minus 84,623 euros for the sales price, which is not right. So this is a bad record. And you can see the reason given for quarantining it. So it's invalid or missing sales price. So this is why it's in quarantine table and it's not flowing into our main data pipeline or into our fact or dimension table. It's present in the quarantine. So with this, we can take a look at the source and see if there's a problem there, because it can be right at the same price. It's like you are buying a property from somebody and the person is the person paying you. Instead of paying the person for buying the property, the person is paying you for buying the property. So in our case, it might be possible, but in our case, for this particular data pipeline, it's not possible. So we already said that. So that's why it's in the quarantine table. So now we are done deploying to production environment as well, production workspace as well. We need to go to the next step, which is to create our unit test and integration test, so that we can handle our deployment automatically via our CI/CD pipeline. So that's what we are going to do next. So before I go to the CI/CD part, so let's take a look at the jobs that I activated. So it has finished running. You can see both the neighborhood and report and the property violation reports, they both run successfully. So that means our deployment is working fine for development, and then it's also working fine for the production. So now that we are done with our deployments to dev and the production workspaces, I think next thing will be to handle our testing. And for the testing, we're going to have the unit test and the integration test. For the unit test, we are going to test our bronze transformation functions or methods. We're also going to test our silver transformation methods as well, and also test our gold transformation methods. And then for the integration test, we are going to carry out end-to-end pipeline tests to be sure that all the transformation from this bronze to silver, then to gold, everything works out the way we planned it before maybe deploying. So that is what you are going to do next. And this is vital because if you are going to automate our deployment via CI/CD, we want to be able to, each time maybe changes are made to our logics, we want to be able to make sure that our existing transformation is maintained before we can merge our changes from the development environment or development branch to the production branch. So in this case, the CI part of our CI/CD is going to handle this testing and the deployment to development part, while the CD part is going to handle the deployment to the production or main branch. If all the tests we are going to write now pass, if the tests fail, that means the option to merge our changes to the production branch won't be possible. So here we are going to have two kind of tests: integration test and then the unit test. So let's start. Here we have, by default, we have this test. So let's delete this. We don't need it. So let's create new folders. Within this test, create a new folder. We'll call this integration. It's our integration folder. And then let's create another folder within test as well. We'll call it unit. So have both integration and unit test. So within the integration, we are going to create this another folder, call it the full pipeline. The reason we are not creating the files directly within integration, because we might want to test, we might want to have different kind of integration tests. We might want to test from bronze to silver separately. We might want to test from silver to gold separately, and we might want to test the full pipeline separately. But what I'm covering here is just for the full pipeline. That's why I had to create a folder for the pipeline. But just in case maybe one is working in the production settings, you have to maybe have these different integration tests incorporated. But for now, we are going to use only full pipeline for the integration test. And then we are going to make it a package. And we are going to have within this full pipeline, we're going to have another file. We are going to name it expected trends.json. This is going to contain the expected data, because we are going to use static data for this test, and the static data we are going to have the input data and the expected data. So in our case, because it's a full data pipeline test, we are going to have the input data as our raw data, which is our bronze data, which we are going to create here as well, and we're going to have the expected data as the two tables we generated from our gold layer. So coming from the source to the final output we have within our pipeline. So that is one of the expected. Let me just name this another expected, create another file. This is expected as well, because we're going to be expecting two tables. So we are going to create a static data for these two tables. And then we are going to have the input. The input in this case is supposed to be our raw data, which is like our bronze raw data. So this is our input, and then we are going to have test module. In this case, it's going to be test full pipeline.py. So I'm going to populate these files now. This is our static data, mock data, which we are going to use for this full integration test, full pipeline test. And here the input is going to be our silver raw data. Our bronze raw data. As you can see the format, this is what you are going to input into the test, and then we're expecting it to, after carrying out all the transformation from silver and bronze, from bronze to silver, silver to gold, we are expecting to have these two gold data, this, and we're also expecting this So these are the gold layer tables that we created. These are like the values. So if you impute this, we are expecting something like this and this, and especially the values and the data types and all that. So these are the data for the test, and now we have the test script, which is this. So basically, here we have the load JSON to DF, which basically allows us to treat expected and imputed data as a real Spark data frame for basically comparison and the transformation. So then we have the second function, the assert df equal. So this part basically ensures that our result and expected output match structurally and content-wise. So regardless of the internal Databricks quirks like column orderings or type metadata. So that's what this part actually does. And then this is the part that now tests the full pipeline. Here we have input data. The input data, we are giving the paths to our input data here, which is test, integration, full pipeline, and we have the input data. And then we have the expected gold part, and we have the expected trend part. So both of them are also given. So now the input df is we are going to use the load JSON function that we created here. We're going to use it to load our raw data. And then the expected gold, we're also going to use to load our expected gold and also use to load our expected trend here. And we are going to simulate the bronze ingestion. So because we are not going to connect to stream, we're not going to use DLT to stream our bronze data. We are creating it statically here as a mock data. So we are going to now mock the bronze data here. So from this bronze data, we are now going to look at what we are testing here. We are testing several steps here from our silver processor, which we created within the silver layer. Here's the silver layer again. This is the pipeline. This is a silver layer. So we created silver layer here. So we have silver processor. So now let's go back. We are saying from our silver processor, here we are creating the silver processor object and silver processor object, so which accept the bronze test table as one of the parameters, and then also the Spark session. So once we create the silver processor, we're now using the silver processor to basically call the method within the silver processor. The first method is this flattening property. The second is process, and then we have transform and we have this. So let's go back. So you are now seeing that we are using this silver processor to call this flattening property data, and then we are passing the raw df into it. The raw df now is this, which we just created. And then also the fact table, using the same silver processor, we are going to call the transform transaction fact method by passing the flatten df down. It's just like a process for one process to the other. And then we are doing the same thing for the df using the flatten df as well. So to call the function, the method as well, and then pass the flatten df into it as the parameter. So each step we are testing here. So then we'll now go to gold. From gold, we are creating the gold object here, gold processor object, using Spark as the parameter. So now we have from the gold processor, we have the aggregate property valuation. This is our good. Let's take a look. We have two methods: aggregate property valuation, build neighborhood trend. So we are going to test these two as well within the full integration test. So we'll come back here. So we have from the group processor, we're also testing the aggregate property valuation method, where we are going to pass two data frames, the fact and dimension tables. And then we are also going to test the build neighborhood trend, where we are going to pass the dimension table as a parameter as well. So this final part is the assertion part, where we'll now compare both the input and the expected. If everything goes on well, the schema is okay, the value that I expected are okay, everything is fine, then the test is going to pass. But if anything is missing, then the test is going to fail. Now, this is important because if we are trying to merge our changes that we just made from development to production branch or main branch, we should be able to test all these processes and be sure, using static data, and be sure that everything is still working as expected. So if the functions here pass all these processes, then it simply means that whatever changes that were made it's not basically distorting what we already have within our production environment. So in that case, we can merge our changes to production. But if anything changes, which we don't want, then it means that's an error. Then we'll have to take a look at it again and make sure we correct them before we merge the changes to production. So that is what this full integration test is doing. So the next thing we're going to do is the unit test. So for the unit test, I've created the folders that are needed. This is the folder for unit test. Click on it. So within the unit test, we have a folder for the bronze, we have folder for gold, we have the folder for silver. And then within bronze, we have another folder for data, which is our static data for the test. We have this, the expected ingestion raw property data and the input raw property data. So now for this bronze data, remember we said at the beginning that we are not going to perform any transformation within the bronze. The bronze is supposed to be in its original native format. So that means our expected here, or our input here, you can see that our input, which we have seen before, will be equal to the expected. So after the transformation, or after running the functions that perform, the autoloader function that perform this bronze function, we expect that it's not going to change the structure of the data. Everything will still remain the same. So here, input is supposed to be equal to expected. So that's why we have the same kind of structured data in the input and the expected. Now in the logic, this is our test bronze logic. So we have, just like we did in our integration, we have a load JSON as df function, and then we have this function, which basically here we have the test ingest raw property data schema content. So here we are imputing our input data and our expected data. We are given the paths, and then we are using this load JSON as df function to read this input and expected using Spark transformations. So now ingest property data, this is the function we are trying to test from the autoloader. So let's go back to our bronze. So you can see the ingest raw property data. So this is from our autoloader. We want to test this particular function to be sure that it's working well whenever changes are made. So let's go back. So by doing this, we have to create the object first. And to create the object, we did this, and then we now set the. So basically, what this part does, we are trying to make sure that the schema and the first record for the result D is equal to the expected DF schema and also the record that is present there. So if there's any mismatch, then it's going to be an error, and then this test is not going to pass. But we expect that there was not going to be a mismatch. So that's what the test is all about. And then this part basically ensure that data frame structure for both the expected and the inputs, they are in alignment. So basically expecting that the data frame structure is as expected. So if the structure is kind of a mismatch, then there's going to be error. So that's what this part does. So we have two assertions here for this bronze data, this bronze test. And within the silver, we have a folder for the data. This is the mock data, the static data in this case. We have all the expected. We have the expected transform, we have the expected fat, we have the expected dimension, and we have the expected flatten. And then we have the input for fat, input dimension, and input flatten as well. So these are the mock data we are going to use for the silver. And then what are we testing in the silver? We are testing because it's a logical step. We have different methods that we are going to test. Let's just refresh our memory with the silver. This is the silver.py. So we are going to test the flatten method. We are going to test the process data method. We are going to test the transition fat method, and we are going to test the transform property dimension method. So be sure that these methods are working very well whenever we make changes. So let's go back. Here you can see the first we have to import. Here we imported the silver processor from this silver properties module, and here these are the main tests we are carrying out. The def test flatten property data, you can see where we created the result df object using the silver processor. So processor.flatten property data. So this is the method we are testing here. We are using this now. So now we say assert df equals result df, which is this now, is equal to and the expected df. So we are comparing these two. And the second one is test process date, which is the second logical step or method in our Silver class. So here we have the processor dot process data. So this is our process data method, and we give it the input, and then this is our assertion. And then we have the next one, which is the transaction, the fact method test. So you can see here we have the transform transaction fact, which is also created in our Silver module. So here we'll give the input df, and then we'll perform the assertion here, comparing both the result and the expected. And then also finally do the same for the dimension. So we also use the transform property dimension method. We are going to test this and then also compare the results. So these are the tests for the Silver. I will have the GitHub to this particular project also within the comments, within the description section, so you can also visit it and take a look. And then let's take a look at the good. This is the good. Within the good, we have the data as well. So we have the expected, and then we have the input. These are the mock data. And then this is a good script, just like we did before. Here we are testing the aggregate property violation. So this is the method which we are testing to be sure that it's working well using the mock data. This is where we imported the mock data. And we're also testing the build neighborhood trend method. So this is the other method we are testing. So, and then we'll compare the result and the expected. So if all these tests pass, then we can always make our changes. If any of the tests fail, then we'll have to go back and correct whatever is failing. So this is that for the unit test, but we have to run it locally. And to run it locally simply means that we'll have to install Spark local machine to be able to run this test. So that is what we are going to do next. So installing the packages within my requirements dev.txt. So I'm installing the PySpark, Pandas, Pytest, and setup tools and wheels. So those are the things I'm installing because I need the PySpark to run the Spark to run the test locally. So I need the PySpark. So now we have installed the PySpark, this particular version of PySpark, and also Pytest, because we'll be needing the Pytest for our unit and integration test. And after installing these two, we have to make sure that Java is installed locally within our system, and the Java part is also set. And also here we can, within our PowerShell, we can run this. So this basically tells Spark which Python executable to use to launch our Python workers. And in addition, we have to also run this, which Python executable to use to basically launch our Python workers. So that is what this does. So after installing the PySpark and then the Pytest, also making sure that we have Java within our system locally, and then now we can run the Pytest because we have finished developing the Pytest. So let's type Pytest and then we run. So here we have 8 items collected, basically 8 tests that we are going to run across both integration and the unit test. We have 8 items to run. So now it's running. So let's wait a bit. So now we have finished running the unit and integration test. As you can see here, the configuration file is the pytest.ini, which is this. So within this configuration file, we are going to set the test part. The test part here is going to be in test, which is this. And then we are going to set where we are going to find the source code, which is going to be in our SRC folder. And within the SRC folder, we're going to go into pipeline Silver for Silver. We're going to go into pipeline Bronze for Bronze, and we're going to go into pipeline Gold for all the gold modules. And here we have the Bronze module, and here we have the Silver module. So we have to give this part this way. Otherwise, you are going to have errors like a pipeline module not found, or source SRC module not found, something like that. So you have to give the part here in this Python part. And then the adopt basically is going to tell you how you want Pytest to display the messages. So here we have a total of 8 items, and you can see 8 passed. within 137 seconds. And then after the test pass, you can see the Spark session terminated automatically. So now we are done with the integration and unit test. And then the next thing we are going to do is we're going to write our CI/CD configuration now to make sure that we have the unit and integration test run during the CI. And then if everything goes well, then we can merge our changes to the main branch. So now we are going to write the CI/CD part. So now we are done with the unit and integration test. We have to work on our CI/CD part. So here I've already created the .github folder, and within the .github folder, I created the workflows folder, and within this workflows folder, we have the CI and the CD. First, let me explain the CI. So in the CI, we are going to have it triggered in the development branch. The CI is going to be for the development branch, which is going to handle the testing and then deployment to our development. So here we have on push to the dev branch or pull request that targets the dev branch. We want you to actually run this CI. So we have the jobs within this CI, and the job is deploy and run dev. So here we have the steps. And the steps here, we are installing the Databricks CLI, which is this. We are using this to install the Databricks CLI, and then we are installing our requirements dev.txt. And then after that, we are going to run our test. And before we run the test, we are going to set the Python part, just like we did in our Pytest in .ini. So just like we did here, we are going to also do the same thing here. Here we are giving it the paths to our source modules. So here, after that, we are now running the Pytest. So if the Pytest, every test within the Pytest pass, then we are going to go to the next step, which will be to deploy the bundle to development environment, just like we did earlier on. But in this case, we are using CI/CD to automate the deployment. So if the test pass, then we are asking to deploy to the development environment or workspace. In order to do this, we are going to need a Databricks token. So this token we are going to hide within our repository secrets, and then we are going to give the environment where we want this token used, which is the development environment. So after this, we are going to now run our pipeline, development pipeline. Basically, after deployment, we'll run the pipeline. So in this case, this is the command we are going to use to run the pipeline, which is refresh all. Again, we are going to give our development token and then define the environment where it is. So this is going to be our workflow for our development, our CI part, which is going to handle our testing and deployment. So basically, if any of the tests fails, like we have 8 tests here, if any of them fails, it's going to terminate here. So it's not going to go further to the deployment. So we are going to handle what the issue is before we have to go to the deployment. So the test must pass before we deploy. So, and then if we deploy and then we look at our data within the development workspace and everything is in order, then we are going to create a pull request, and the pull request is going to, let's just go to the CD and explain that part. So you can see the CD part, push to the main branch, and this push, for us to have push to the main branch, we can push via locally, or we can also push if this main branch is being targeted via pull request. So if there's a pull request that targets the main branch, then we merge the changes based on the pull request that was created, then it will basically activate a push on this main branch. And then that is only when we are going to have all this run. Then we are going to have deploy and run bundle in production. So in order to do this, we still follow the same step as in CI, and then we install our Databricks CLI, install our requirement.txt, and then we will run this command, Databricks bundle deploy. But in this case, we are deploying to production, and then we are going to use production token for this, for authentication in this particular case. So after the deployment, we are going to run the pipeline again, and then using the same token as well within the production environment. So what this does, basically, it's fetching the environment from our databricks.yaml file based on our configuration here. So this is where it's going to fetch it. So Databricks bundle environment. it's going to fetch it here. So this is how we have configured this. And other ways, what else we are going to do is basically to protect our main branch via GitHub, where we don't have to have the option to push to the main branch locally, because that would be dangerous if we have the option to push to the main branch locally without via pull request. So we can also protect our main branch from GitHub. So this is our CI/CD setup. So now let's initialize this project for, let me first of all clear. So let's initialize git init. So we have initialized, then let's add everything, git all, then we have added, then let's commit git commit, let's say initial commit. So we have committed, and then this is the master branch. So let's rename it to the main branch. So say git branch main. So I've renamed it to main branch. So let's create our repository remotely. Let's go to our GitHub. So here we are trying to create a new repository. So give it a name, Databricks Asset Bundle Real Estate Data Pipeline YouTube. So we are using this for now. Let's keep it private. So let's create. So let's copy this. So we have added this. So let's push to the main branch. So let's see if push was successful. So the push was successful, and now because we push to the main branch, let's see the GitHub action, it's deploying directly to the main branch at this moment. So let's just cancel the workflow. So I've canceled the workflow. So let's create a dev branch. Let's say git checkout. So let's create our dev branch. So say git checkout dev. So now we are in dev branch. So let's git push origin dev. So let's see how we can generate this Databricks production token and also the development token. So from Databricks workspace, let's see how we can generate it. So let's go to Databricks in our development. In order to generate the user token for our development workspace, let's click on this, then click on settings, then click on developer, then you can see access token, click on manage, then you can see generate new token. I already generated one, so I don't need another. So it generates new token, and then to save it as a secret within GitHub repository or repository here. So come down here, click on settings, click on secrets and variables, action, and then you have a new repository secret, click on it, and then you give the repository name. Like in our case, the name is Databricks dev token, click on it, and then we'll add the value. So I'm going to do this now. The Databricks dev token and the Databricks prod token. So these are the two secrets I've added within this repository. So now let's go back. Let's say git push origin dev. So we have pushed to dev environment. So let's see. Dev had recent pushes 3 seconds ago. So let's compare, create a pull request. I just create a pull request. So you can see to merge here, we don't have the option highlighted at the moment because we need this test to pass before we can actually merge our changes to the main branch. So let's click on this. So you can see deploy and run bundle. So it's running the test. Collected it, I can see the steps, check out repository, set up jobs, check out repository, set up Databricks CLI, install development dependencies, and then run the test. So the test passed successfully. You can see it passed. So because the test passed, the bundle is now deploying to development environment. So here we say deployment complete, and then the next thing is it's running the pipeline now. So let's check out development environment. Let's go to jobs and pipeline. So you can see here, let's click on it. So you can see the same thing that is happening within our GitHub action is also happening here, waiting for resources. So let's wait and see what happens. So we have finished deploying. You can see complete job. You can see this part, run dev pipeline job, everything completed. So you can see completed here. And then in Databricks, you can see it all look like there's no record here because we already created the tables when we deployed locally. We created the tables, and then now we are still using the same data to populate because it's an incremental table, especially the streaming tables. These are incremental, so no new records were found, and then because no new records were found, the tables were not updated with new records. So basically what we are trying to inject into those tables were existing data because they are incremental. So that's why you can't see any count here. But for the materialized view, you can see because each time it runs, it runs a full refresh on these tables. So each time it runs, it gives you a full refresh of these tables. And now, because it's full refresh, it has to, do the whole thing all over again. And then here again, it appended about 20 records, and here another 20 records, which is what it did the first time we ran it via our local deployment. So now there's nothing here, no new record to append to this part because it's incremental. But here it's a materialized view. So full refresh was carried out, and then the records were again, added to these particular tables. Now let's also check again. Now that we have completed this part, let's go back to pull request. So you can see we now have the option to merge our pull request. Tests and then deployment to our development environment have all checked, and everything went well successfully. The test didn't fail, and then the deployment didn't fail, and then running of the pipeline didn't fail. So everything ran successfully. So we now have all check passed in this case, because these are just the only constraints that we are placing on this pull request. So here we'll have the option to merge pull request, which will basically push to our main branch. So let's merge, confirm merge. So let's go back to our action again. So now that we have merged, you can see deploy and run bundle in production is taking place. So click on it. So it's now deploying to production. So let's verify this from our production environment, production workspace. As you can see, we are in production, and this is the real estate pipeline. Let's click on it. So you can see the same thing is happening now. We are waiting for resources within the production. So as you can see, it has finished deploying to the production workspace. So you see here, run production pipeline job. You can see completed, and then within the production workspace, you can see we are in production here. You can see the lineage graph. For the streaming tables, there's no new data arriving, so you can see it's completely flat, no record here. Unlike when we ran it the first time, look, this is the first run. The first time we ran it, had 15,000 records, 24,000, 13,000, and 6,000 in quarantine. Then for the materialized view, we had 2020 records. Then now that we'll just finish running it again via our CI/CD pipeline, you can see because there's no new data arriving, this part is completely empty, so no new record. But here we have 2020 record again, because most times, each time it runs the materialized view, it's usually full refresh of the whole table, and then it appends the same data again for this particular time. So we have 20 records again, because this is materialized view, and these streaming tables for the bronze, silver, and then the gold is materialized view. So now we have deployed via the CI/CD, and everything worked as expected. If you go back here, so you can see for Databricks Asset Bundle, we can now manage this deployment via CI/CD. So whenever any changes are made, we basically run the test again, the Pytest unit and integration test, run them, and if the test by any means failed, that means changes have been done that we don't want to actually affect our production branch. So we have to go back and correct those changes, especially if we don't want to make any changes. So that is the essence of this CI/CD, and this is a core part. Like I said before, this is a core part of our Databricks Asset Bundle, because with this we can be able to manage our deployment. So this is an end-to-end data pipeline. Basically, I'm reading data from our cloud storage. If possible, maybe we have streaming data. We can also use a PubSub to actually stream the data and also include it in our pipeline. But in this particular case, we are only reading from our Google Cloud Storage, and then using our different layers to, transform the data from the bronze, which is the raw data, to silver, where we transform to fact and dimension tables, and then to the gold aggregated tables. We have done all that. So, and then we'll now automate our deployment using our CI/CD pipeline part. So now we are done with this project. There's one thing I want to show, which is how we can use a natural language to basically query our data. Let's go back to prod. Let's go to catalog. Here we have pipeline prod. So let's activate our serverless. So you can see this part, explode it in natural language. So let's click on it. First, let's see the data. We are seeing sales price euro, and then transaction price per square meter. So let's see the other features. So let's ask Genie, using natural language, let's ask Genie a question. about this data, because basically it's now me to understand the data we have. So let's ask Genie the question. So let's use natural language. Give me the transaction, the maximum sales price. So you can see it returned this particular transaction ID and then the value. Without wasting time, you can show you the code if you want. All you need to do is to click here and then you see the code that retrieved this particular value. You can also hide the code. So let's ask the question again. Give me the transaction with the minimum sales price. So you can see the transaction ID with the minimum sales price. So with natural language, you can ask Genie the question and Genie basically understand your data within your Unity catalog. So you can also ask questions based on aggregations and all that, even which simply means that every person can actually query our data. You don't have to have the technical skill to actually write SQL queries or Python queries to be able to retrieve the information you need from our data. Our Unity catalog has been set up in a way that Genie can understand our data basically. So you can ask your question using a natural language and you get your answer. So this brings us to the end of this end-to-end Databricks Asset Bundle data pipeline. And in case you have any question, you can drop it in the comment section. We'll be able to try my best to answer it. Today, basically, I'm using my holiday to prepare this particular video. I hope you basically like it, and then if you like, kindly like it, and then also subscribe to my channel. So thank you so much for watching, and bye bye.